All right, so today we are going to build on the review from last time, where you just reviewed the three basic trigonometric functions, sine, cosine, and tangent, right? Well, today we're going to introduce three more trig functions, and then talk about how to use the calculator to get the different values that we need from them. Okay, so there will be in total 6 trig ratios that we have to know and be able to use, those to find missing sides and missing angles. Okay, so like I said, from last class we reviewed that from a particular angle in a right triangle, the sides are labeled as follows. The hypotenuse is always the guy across from the right angle. If this is the angle that we're referencing, then the opposite side is over here, the adjacent side is over here. Obviously, it would switch around if the theta was over here, if the angle that we were referencing was over here. The hypotenuse would stay the same place, of course. And you also were able to review the fact that Pythagorean theorem is what we use to talk about side lengths of a right triangle, find missing sides if we have 2 of them. But if we don't have 2 of them, then we have to fall back onto our trig. Okay? Okay, now, so sine, cosine, tangent we reviewed. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. 3 new trig functions, and those trig functions come from just the reciprocals of the original 3. Since the side lengths are predictable, the relationship between the side lengths is predictable in a right triangle. Talking about the reciprocal of those relationships makes enough sense too. So cosecant is defined as the hypotenuse over the opposite, so it's just sine flip-flopped. Secant is the hypotenuse over the adjacent, so it's just cosine flip-flopped. And then cotangent is just defined as the adjacent over the adjacent over the opposite, so it's just tangent flipped over. So what we got to remember though is that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and tangent is the reciprocal of cotangent. It seems like cosecant and cosine should go together, but they don't. So just remember that cos are split, and the tangents go together. Make enough sense. Okay? All right, now that we know that. So SOHCAHTOA is going to get us into our sine, cosine, and tangent. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. I think it's still very helpful to start there with your thoughts and then go to secant, cosecant, and cotangent based on which ones they're supposed to match up and flip them over. Okay? So we'll get to a quick example here. Determine the values of all 6 trig ratios now for angle beta, and beta obviously sitting right here. So we start. Sine. Sine is opposite over hypotenuse, so the opposite is 6, hypotenuse is 7. So 6 over 7. Cosine would be adjacent over hypotenuse, but obviously we don't have the adjacent, so we've got to go find it. So 7 squared equals 6 squared plus x squared. So 49 equals 36. And then 13 equals x squared. And so the missing side here is the square root of 13. Okay, so now cosine of beta would be the square root of 13 over 7. Tangent is going to be 6 over the square root of 13. Except you can't have a radical in the denominator, so don't make it a decimal, leave it as a radical, just rationalize that denominator. Now we do that by multiplying numerator and denominator by the exact same radical, radical 13. But if you haven't noticed this yet, there is a quick way to rationalize this denominator, and it's simply a matter of bringing the radical 13 up with the 6, and then just dropping the radical in the denominator. That's how it's going to shake out if you go through the calculation itself. And so 6 radical 13 over 13 is what we want to use for the tangent. Now, cosecant. Cosecant is the reciprocal of sine, so we go 7 over 6. Secant is the reciprocal of cosine, so we go 7 over the square root of 13. Now apply the trick. move the radical 13 to the numerator and drop the radical in the denominator, so 7 radical 13 over 13. And then cotangent, just flip over tangent, and so 6 over 7. Okay? Hopefully that's a piece of cake. Now that we understand, and we're starting to think about these trig functions in terms of ratios. They're ratios, and we want to keep writing them down as fractions. I want to see the two side links that we're using to put together those trig ratios, so that if we're given one trig ratio, we can go find the rest of them. Right? For example, here we've been given that cotangent is the square root of 3. Well, as a fraction, that's the square root of 3 over 1. So if we were to go into and label the triangle given, or draw our own triangle and label it, cotangent is, let's see, tangent is opposite over adjacent. Cotangent is adjacent over opposite. So from the angle beta, adjacent has to be the square root of 3, and opposite has to be 1. Right? Because cotangent is adjacent over opposite. Okay? Now that we have two sides here labeled, we can Pythagorean theorem this. Get 9 plus 1 is 10. So we get the square root of 10. Just kidding. The square root of 3 squared is 3. 3 plus 1 is 4. And the square root of 4 is actually 2. Okay, so now we have all three sides. And we can go through all of our trig ratios. Sine of beta is opposite over hypotenuse, so 1/2. I need to change colors here. Cosine of beta is going to be adjacent over hypotenuse, so radical 3 over 2. Tangent is going to be opposite over adjacent. Rationalize the denominator, bring the radical in the numerator, and then drop the radical in the denominator, so radical 3 over 3. Cosecant, flip over sine, so 2 over 1 or 2. Secant, flip over cosine, so 2 radical over radical 3. Rationalize that denominator, and you get 2 radical 3 over 3. And then we're done. Okay? All from starting from one trig ratio. Okay, now, learning how to get values out of these trig functions. So remember that sine, cosine, tangent, those have to have an angle come along with it. And all of these did in the previous examples, only we didn't know what the angle measure was, so we just gave it a variable. Beta, this Greek letter beta, is used often enough. Theta is probably used the most often. So there's still an angle attached to it, we just didn't know what it was. Here we have the angles. And if we have the angles, then it helps us get the actual value out of the trig ratio. Okay, so if we want to find out what sine of 49 is, then we'd simply type it in, right? So sine of 49 degrees. Right? You get 0.7547. So you can write that down. Now, if you didn't get that, it might be because you're not in degree mode. So check the mode of your calculator. Here you just hit mode and go down and make sure that degree is highlighted. If it's not, arrow down and over to it and hit enter, and it will highlight it for you. All right, so same thing with cosine of 120. Back up. Now, I know what you're thinking. Wait, Mr. Smith, from geometry, we don't have a 120 degree angle. You can't have a 120 degree angle in a right triangle. The answer is, and that's true, but what we'll find out is that we will actually be able to find the cosine of 120. You hit enter, and it's negative 0.5. All right, and then the tangent of 52, we're back to a more normal angle measure. Oops. You can get 1.2799. Okay? So there you go. Now, next, in your notes, cosecant, secant, and cotangent, right? Here, if we want to find those values, then you have to understand that these are all reciprocals, right? So cosecant theta is the same thing as just flipping sine theta over and making it 1 over sine theta, right? That's the reciprocal. Yes, I know before we did them with the particular side lengths, the opposite, adjacent, hypotenuse. But we can also think of it as one trig function to the next, cosecant being 1 over sine, secant being 1 over cosine, and cotangent being 1 over tangent. So that if we want to find the cosecant of 49 degrees, you'll notice you don't have a cosecant button on your calculator. So what you do instead is you type in 1 divided by sine of 49 degrees. Okay? And that would look something like this in your calculator. So 1 divided by sine 49 degrees, hit enter, you get 1.325, and that's the right value. Okay? Same thing with secant of 120. So secant is the inverse of cosine. So we go 1 divided by cosine of 120, and you get -2, which should make sense from the fact that cosine is 120. Cosine of 120 degrees is -0.5, but we'll leave that for you to discover on your own. And then cotangent of 52 degrees is simply 1 divided by the tangent of 52 degrees. Okay? All right. Good. Now, using these trig ratios to help find missing side lengths in a right triangle is where we want to go. So, bring it back to here. So, now I want to find these missing values. I want to find x and y. Y is the other acute angle in this right triangle, and hopefully you remember that all you really have to do is take 90 minus 15. Subtract the other angle from 90 degrees. Those two angles have to add to 90. And so that's easy enough. To find the missing side length, to understand that we have a side length of 100, we're missing this, this side here, but we don't have the hypotenuse either, so Pythagorean theorem is not going to help. But what we do is we take a look. We have this angle. From this angle, we have the opposite, and we want to find the adjacent. Tangent is that function that uses opposite over adjacent, so we could go tangent of 15 degrees. Remember, the 15 has to go with tangent. Equals, and then our ratio, opposite over adjacent. And from here, whatever method you use to figure this out, what I talked about in geometry before, last year, is that if x is down low, then you want to switch these two and get to a realization that all you do is divide 100 by tangent of 15 and get you 373.2, round to the nearest tenth. Okay? All right, same thing here. Again, y is the missing angle, so just subtract 90 minus 40, and we get 50. And then instead of using the 50-degree angle, though, go back to what you were given. Always use what you were given to do different calculations. Don't ever base a calculation on yours if you can help it. Just on the off chance that you did something silly and missed the first calculation, then you'll miss the rest of the calculations as well. Right? So, anyway, we're back to the 40-degree angle. We have the adjacent, and we want the adjacent, and we have the hypotenuse. And so that's going to get us cosine of 40 degrees equals x over 80. Now, here x is up high. If x is up high, then multiply. right? So we get 80 times cosine of 40. And that gets us 61.3. Okay? All right. Now, if we don't know the angle, right? So in the last sort of set of slides, last couple of slides, we had the angle measure. And so sine, cosine, tangent of the angle measure, we can actually punch into our calculator and get a value. Here, we don't know the angle measure. And so we have to solve for theta. There has to be some way to solve for theta. Well, inverses are how we undo things in math. So we got to take the inverse of sine. Now, understand that the inverse of sine is not cosecant. Inverses and reciprocals are completely different. All right? So when we get theta by itself here, we have to type in inverse of sine of 0.9677. Okay? So what that looks like, right, is going to be this. Inverse of sine would be second sine of 0.9677, and hit enter. And so your angle measure is 75.4 degrees. Okay? Same thing for tangent of theta there. We want theta by itself, so we have to second inverse tangent, and then type in 1.474740, and get 55.8 degrees. Now look at the last one, secant theta. We've got to bring that back up here because, again, we don't have a secant function in our calculator, and we can't hit second secant. So go to inverse secant. So what we do is that, again, we understand that secant theta is the same thing as 1 over cosine theta. And I'm going to make this into a proportion by putting the 1.055 over 1. And then we can talk about just solving here. So cross multiply. And you would get 1.055 cosine theta equals 1. And then divide both sides by 1.055, and you get cosine theta equals 1 over 1.055. Now we can inverse cosine, and it gives us a value to inverse cosine. So, what does all that mean? The moral of the story is secant, cosecant, cotangent. We can still use those functions to find an angle measure, and we can still work our way into an inverse. But with secant, cosecant, and cotangent, we have to revert back to the original 3 that corresponds to it, do the inverse of that, so the inverse of cosine, but do it for 1 over the value that we've been given. Right? And that'll give us theta. So 1.055 is here. What we do is we go 1 divided by inverse cosine, because inverse cosine matches up with secant, and we go 1.055. Oh, what did I do? Typed this in all wrong, is what I did. So we go inverse cosine of 1 over 1.055. Sorry. Okay? And get 18.6 degrees. All right? So if we want to do inverse secant, cosecant, cotangent, just do the inverse of the original 3 that it matches up with, but make the value that it's equal to a reciprocal. So here we had to just put 1.055 over 1 and flip it over and get 1 over 1.055. Okay? All right, last couple of examples here. We want to find x and y. Now, looking at this, hopefully, you realize that y is kind of, well, straightforward. Not easy necessarily, but straightforward. You got Pythagorean theorem. So y squared equals 12.5 squared plus 16.2 squared. And doing some button pushing here. Y squared is equal to the square root of 418.69. And then square root that. And we get 20.5. So y is 20.5. Okay. Now, to find the angle measure x there, we have options. We can actually use, we have opposite and we have adjacent. I want to use the two sides that have been given. We could use tangent, or if you really wanted to, we could use cotangent. But I'll go into the more straightforward way and do tangent of x equals 16.2 over 12.5, and then understand I have to do the inverse to find the angle measure. So inverse of that fraction, and we can type it in just like that, right? So we can type it in as second tangent of 16.2 divided by 12.5. And we get our angle measure of 52.3 degrees for x. Okay? And this is kind of getting us into solving an equation so we can find any value that we need. Right? Same thing for this last guy. Find x and find y. I'll give you a second to work through that. You can stop the video and then pop it back up and check your answer. Make sure you're doing okay. Okay, so did you get 14.5 for x and 71.7 degrees for y? Hopefully you did. If you didn't, come in during STAR. We'll talk about it and see what may have gone wrong. All right? But that's it. So go ahead and knock out your homework in Canvas, and we'll see you guys next time.